Good morning. I'm going to go through the homework solutions of the homework that you had yesterday. So the first question, question 3, talked about rationalizing the denominator. So we had done this in class and hopefully you were able to follow along. First question, 1 over the square root of 3. We're going to multiply the top and the bottom by the same thing, by this third that's down here, the square root of 3, and we get the square root of 3 divided by the square root of 3 by 3, which is 9, and that's the square root of 3 over 3. So that's our answer. Part B, we had 2 over the square root of 5. So what I multiply by, top and bottom, is the square root of 5. 2 times the square root of 5 on top, the square root of 5 by 5, 25 on the bottom, and we must simplify that to 2 root 5 over 5. Part C, we have 2 over the square root of 2, multiplying top and bottom by the square root of 2, gives us 2 root 2 over square root of 2 by 2 is 4. That's 2 root 2 over 2. And now we notice something. If I have the same number top and bottom, they divide in to give me 1. And the answer here is just the square root of 2 on its own like this. And of course, at any step, if you're not sure if you've simplified it properly, you can always just type it into your calculator to check if you've gotten the expected answer. So if I type 2 over the square root of 2 into my calculator, it will rationalize it to the square root of 2. Part D, a similar kind of pattern, 7 over the square root of 7. So you could probably guess we've got the same pattern as here. The answer should be the square root of 7. Again, we can check it in our calculator. I multiply the top and the bottom by the square root of 7. So I have 7 root 7. Let's start to take a shortcut here. We know this is going to be the square root of 49 and that's going to simplify to 7. So then that whole thing simplifies to the square root of 7. Part E, 3 root 3 over the square root of 7. Multiply the top and the bottom by the square root of 7. We get 3 times the square root of 3 by 7 is 21 over root 7 by root 7 is just 7. And you just leave it like that. There's no need to go any further. F, 4 over 3 times the square root of 6. Now the only thing I need to multiply by is the third part. I don't need to do anything about this 3 that's down here. It's fine to have numbers on the bottom so long as they don't have a square root sign in them. So I get 4 root 6 on top, and I get 3 by root 6 by root 6 gives me 6. So this gives me 4 root 6 over 18. And if you type that into your calculator, you'll notice it simplifies it a little bit further because 2 divides into 4 and 2 divides into 18. So our final answer here is 2 root 6 over 9. And part G, root 5 over root 75. Okay, before I rationalize the denominator here, I can see that 5 goes into 75. Now it's fine if you rationalize the denominator the way we've done it before, but because I can see that 5 goes into the square root of 75, I might decide to simplify this and have 1 over the square root of 75, like this. And then I can multiply the top and the bottom by a slightly smaller number. You'll start to notice if you've 1 over the square root of a number, that will always rationalize to the square root of the number over the number. If you spot that pattern, you can start to jump straight to it as well. But for the moment, we're working through how we get this. So we get the square root of 75 over root 75 by root 75 gives me 75. There's my answer there. And part H, a similar kind of thing, root 32 over root 256. Put this back onto the screen. I'm going to bring my square root sign over it. And 32 actually divides into 256. That goes in 8 times. So this is 1 over the square root of 8, which gives me root 8 over 8. But there's something further we can do. The square root of 8 simplifies to the square root of 4 times 2, because there's a perfect square that divides into 8, and that gives me 2 root 2 over 8, which simplifies to the square root of 8 over 4. Square root of 8 over 4. I've got a bit blurry. Okay, so that's rationalizing the denominator. In questions like this, you don't have to show a million steps. Usually about 3 steps is sufficient for what they'll look for in an exam. You would not get full marks if you went from here to here. And I made a mistake in what I wrote down. This, of course, is the square root of 2 over the square root of 4. Square root of 2 here and the square root of 2 here. Just to write that down properly. Okay, so you won't get full marks if you go from here to here, but you could go from here to here. 1 step, 2 steps, 3 steps. That would be fine. That would be perfectly fine. Okay, let's look at question 4. So question 4 gave us a rectangle with irrational sides. Doesn't have to be a great sketch. 1 plus the square root of 2 is one side, and 7 minus 3 times the square root of 2 is the other side. And we're asked to find the area. And of course, area is length by width. So I just multiply out these brackets the same way I've always done with algebra. 1 times 7 gives me 7. 1 times 3 root 2 gives me 3 root 2. Root 2 times 7 is 7 root 2. And root 2 times 3 root 2 is 3 times 2, because root 2 by root 2 is going to give me 2, like that. Now, hopefully you can see we have what I keep calling like terms. We have the same radical here, which means I can add them together. I made a small mistake there with my signs. This was minus. I have minus here. I should have minus here, which means I have a minus here, and I have a minus here. Let's be careful with my signs. So what I end up with is 7 minus 6 minus 3 plus 7 times the square root of 2. 7 minus 6 is 1. So that's 1 plus 4 times the square root of 2 is our final answer. Units, they didn't tell us. So we can just write down units squared next to it to remind us that we're talking about area. Okay, and the final question that you had was question 9. So question 9 started by asking us to simplify. Part A asked us to simplify the square root of 50 plus the square root of 8 minus the square root of 98 plus 3 times the square root of 2. When we're asked to simplify questions like this, there's no fraction. You're going to look for a perfect square that divides into each of these. So 25 divides into 50, square root of 25 by root 2. 4 divides into 8, square root of 4 by root 2. 49 divides into 98, square root of 49 by root 2, plus 3 times the square root of 2. And we notice that we have the same radical in every term. So we're going to be able to simplify this quite a lot. once we apply our square roots. So the square root of 25 is 5. We've got 5 root 2 plus square root of 4, 2 root 2, minus the square root of 49, 7 root 2, plus 3 times the square root of 2. And then I can just add and subtract all these numbers. 5 plus 2 is 7. 7 takes 7 is 0. Plus 3 is 3 root 2 is our final answer. For part B then, we were asked to add these two fractions, 1 over 27 plus 1 over root 27 and root 12. Now, when I want to add these, it's a little bit complicated because when we add fractions, we need to find a common denominator, but now we're dealing with surds. So first I'm going to rationalize the denominators. And I think that should make my life easier. So 1 over the square root of 27, we know can be written as the square root of 27 over 27, from following the pattern that we've seen before. But there's a step further we can go. There's a perfect square that divides into 27. So on the top we end up with 3 root 3 over 27, and 3 goes into 27, giving me the square root of 3 over 9. So the first part of my sum is actually the square root of 3 over 9. What about the second one? We've got 1 over the square root of 12. And we know, following the pattern from other rationalizings, that that's the square root of 12 over 12. But there's a perfect square that divides into 12, and that's 4. So this can be written as 2 root 3 over 12, which simplifies to the square root of 3 over 6. So the second part of my sum can be written as the square root of 3 over 6. So now, this is the actual addition that I'm trying to do. Square root of 3 over 9 plus the square root of 3 over 6. My common denominator, the number that both of those denominators divide into, is 18. So I'm going to put both of them over 18. This is a single fraction over 18. 9 into 18 goes twice. I've got 2 root 3. 6 into 18 goes 3 times, 3 root 3. And the whole thing becomes, because those are root 2, but I should have written 3. Those are like terms. I have the same radical, the same number underneath the square root sign. This. And so I've got 5 times the square root of 3 over 18. Do I feel confident in that answer? Well, as I keep saying, we can actually check our answer in the calculator. So if we've got 1 over the square root of 27 plus 1 over, be careful how we put this in, plus 1 over the square root of 12, I've got my square root sign, and we get 5 root 3 over 18, which is the same answer that I had there. So I'm happy about that. Now, we wouldn't get full marks for just writing this down and writing this down. In certain cases, you might not get any marks, even though it's completely correct. They want to see you apply at least 3 rules of surds in your working out. So you can skip some of these steps, the way I skipped from here to here. You could probably go straight from here to here, and here to here, common denominator, and show that you know that you can add like surds when they have the same radical. Okay, so today, for the rest of the class, what I want you to do is work on some exam paper questions from surds and finish those off for homework. And then tomorrow, after we've gone through the solutions of the exam paper questions, we're going to move on to indices or powers and the laws of indices. Okay, thank you.